Comparing and evaluating multiple projects using the payback period analysis. So we'll look at both the simple payback period analysis and multiple discounted payback period analysis. So simple payback, you simply calculate the number of years it takes to pay off the investments. In this case, you're investing $40,000, divide by the annual cash flow it generates is 11,000. So you just divide by that to get this total number of year it takes. Now you're getting a negative value because that's a negative sign. So you can simply use a negative sign to get rid of that. Excel is pretty smart, showing me everything in dollar. So these are the simple payback period analysis. Generally in the US industry, it has to be less than 3 years to be economically justified. So only project C makes sense based on the simple payback period analysis. If we do the discounted, it's going to be even worse. So let's do the discounted payback period analysis, which is so cash flow. To calculate the discounted payback period, you can check the video how to calculate the discounted payback period. Basically, you have to calculate the present value for each of these cash flow at different time period, and then you calculate the time it takes to pay off. So this simply you can type this PV function. So each of these you consider those are the future cash flow at this different time point, and then you bring everything to today's value. So I'm going to freeze that rate, and then this will be the number of compounding period for each of these cash flow. There is no payment, and each of these are future cash flow that I'm going to receive at the end of this time period. So simply copy down. Let's see if everything is done correctly. That looks fine. And then we're going to copy it for B and C. So that's for B, and then that's for C. Let's see what's wrong with this. Okay, this should be this guy, and then this should be this guy. So now they're fixed. Let's go down. So these are the all present value. Now we have to get the cumulative present value to find out when we see some positive number. So PV cumulative for A, B, and C. I wanted that to be caps lock. So sum of this first value is the same thing. The second one, that would be equal to sum of this two, and then I can freeze this, and then you will see why I'm doing it once I'm done with this. You see that the way I have made the freezing function there, so I freeze that cell and then leave that other one open, so it's copying down. So it is giving me the cumulative sum. Check that video where I have shown you how to calculate this discounted payback period. Oh, that didn't copy, right? So let's see. So this should be like this, and this should be like this. Now we can copy down. Now as you can see, the project A, you get your money back after 7 years in year 8. In project B, you get your money back in year 7, and only for project C, you get your money back in year after year 4. So none of these are viable based on the payback period analysis. However, if you're just comparing between these three and you're going to choose one based on IRR and PV, everything else, C is the best option. But according to payback analysis, if your payback is 3 years or less, then based on the discounted analysis, none of these projects are really viable, or in engineering economy, doing nothing is an option as well. So in this case, you do nothing.